Hello and a very happy new year to you. I am Dipankar Niyogi and this is my ID. In this comprehensive exam video, I am going to summarize and discuss lessons that I have learned in the program and share my thoughts on some of the cloud computing topics. Prior to joining the MicroMasters program, I had some knowledge of Microsoft Azure Cloud. I passed the certification in developing Microsoft Azure solutions in December 2018. I also had the opportunity to use Azure IaaS for running electronic health information in cloud. The MicroMasters program gave me an opportunity to understand and explore AWS cloud. I would now like to start with the new knowledge that I learned in each of the modules during this program, starting with cloud computing infrastructure. In this course, I learned about the cloud computing enablers like virtualization and networking, and the four most important virtualized infrastructure assets: compute, storage, network, and their supporting services. In compute, I got to know about bare metal servers, containers, and serverless architecture, and how to provision a virtual machine using the cloud infrastructure in AWS. I also learned about automatically scaling our application using auto scaling, managing the traffic for the applications hosted in cloud using load balancer, and using the concept of high availability to ensure that the applications are always available to the user. In storage, I learned about the different types of storage available in AWS: block, file, and object storage, along with the use cases for each of these storage types. In networking, I learned about VLANs and the various cloud services which can be used to secure the network, like firewalls, VPN, security groups, etc. I also got to know about the CIDR notation, which can be used to create subnets within the network. Finally, I got to know how to compute, storage, networking can be configured and managed using the cloud services and APIs. This gave me a very good understanding of how to host these infrastructures in AWS cloud and managing the infrastructure in the cloud. Since I had prior knowledge of creating and managing the infrastructure in cloud, I was able to relate the AWS services to that of Azure. I continued with my MicroMasters journey and completed cloud computing engineering and cloud computing enterprises. I took both of these courses simultaneously. I would like to now share my learnings from these courses, starting with cloud computing engineering and management. Prior to taking this course, I had very little knowledge of cloud migration, the most important issues that we encounter during cloud migration, and some of the best practices to follow to resolve those issues. During this course, I got to know about the cloud privacy and compliance issues, legal and regulatory requirements that we need to account for since the data and application are hosted in a public domain. I was introduced to some of the best practices associated with cloud computing and the process of starting the cloud migration project using Cloud RFP, the components of Cloud RFP that should be included, and the different types of cloud contracts. I got to know about SLAs, SLA templates, which are important in articulating the expectations of the cloud provider in terms of the performance and cloud services. The course also covered cloud SOW, and how the cloud SOW complements RFP and provides additional information which helps the cloud vendor to respond to the customer RFP. In cloud computing for enterprises, I got a very good insight of cloud virtualization techniques and cloud economics. I got to know about software-defined network and how it abstracts the interfaces to networking protocol and hardware devices, which enable us to create and manage network components in cloud. I also got a very good understanding of the cloud economics and how the various cloud calculators can be used to calculate the IT budget and the total cost of ownership. Finally, I got to know to create a business case for cloud adoption by including the key components like return on investment, total cost of ownership, and SWOT analysis. In the last module in cloud computing security, I got to know the importance of security policies and compliances and how it can impact cloud migrations. Also, about security policy templates that could be used to formulate the policy. I also got a very good insight on the various cloud security solutions that are available in AWS, like Cloud Inspector, Shield, Key Management, and Identity and Access Management. I would now like to touch upon what are the most important aspects that an organization needs to consider as part of their initial planning for cloud migration. It all starts with the level of cloud integration. The organization needs to decide on the level of cloud integration, whether they want to go with shallow integration, which is nothing but a lift and shift strategy, or do they want to do a deep integration where they want to change or update their existing application to make it cloud native and use some of the solutions that are cloud related solutions that can be used. Next, they have to establish cloud KPIs because the KPIs are about the application or service that they migrate to measure how they are performing. This will ensure that we are able to track the KPIs once the application is migrated to cloud. Establishing performance baselines is something that needs to be done next. We must do performance baselining of the application and service to determine if its post-migration performance is acceptable or not. Having baselines also enable us to make post-migration improvements. One of the trickiest part of cloud migration is the data migration plan. Since the location of the data in cloud can significantly impact the performance of the application, and we can also run into data compliance issue. Hence, having a robust data migration plan is the key for a successful cloud migration. Disaster recovery and data backup needs to have a well-defined structure. A well-defined data recovery, disaster recovery, and business continuity plan, and a data backup plan using the latest cloud solutions to reduce the downtime in the event of a failure. I would now like to compare the 5 different cloud models, starting with public cloud, which is a platform that leverages a standard cloud computing model to make compute, network, and storage available to the public over the public internet. These are typically grouped as services charged via subscription model or based on usage. Next up is private cloud, which provides a dedicated environment and services for a single company. It can either be hosted on premises or at a data center owned and managed by a third party on behalf of the customer. Hybrid cloud makes use of both public and private clouds. It requires us to move workloads between on-premises to cloud and vice versa. The model is usually implemented when the company wants to have sensitive data in their own premises data center and use the public cloud to scale their application. It can have the benefit of both public and private cloud, but at the same time also brings in operational complexity. Multi-cloud is something that leverages the cloud computing services, storage, compute, and networking from more than one cloud provider. Community cloud is a common cloud infrastructure that is shared between several organizations from a specific community with common concerns or shared interests. It can be managed internally or by a third party and can be a private or a public cloud. These type of cloud models are typically used by government departments or federal agencies. I would now like to shift my focus on some of the risk and security assessment we need to do for cloud migration. Although significant advancements have been made to secure the data and application hosted in the cloud, it still remains as a major concern for organizations migrating to cloud. Understanding the complexity of the cloud migration process and its security implications is very important. Organizations migrating to cloud need to consider technology risks, especially with migrating legacy applications to cloud. These legacy applications may not be built with security, business continuity, or disaster recovery plans, which may hinder their movement to cloud. In some cases, the organizations may have to rewrite the legacy applications. Cloud data governance is another aspect that needs to be considered for cloud migration. Government data protection and privacy regulations require a governance framework that addresses data ownership and retention and the need for multi-country or multi-regional cloud strategy. Organizations migrating to cloud must have a central security strategy in place to ensure policies and procedures that are implemented for access management, data at rest, and in transit. They should also outline the cloud security solutions that can be leveraged to protect the application and data from common threats like distributed denial of service, cross-site scripting, and SQL injection. The next important element of consideration for cloud migration is determine the existing security gaps in the application and accordingly devise the right security policy and choose the right security solutions. Organizations need to do a comprehensive analysis of the current policies, procedures, contracts, and security standards that are in place. I would now like to touch upon some of the current and future trends of cloud computing. Serverless architecture. Startups and smaller organizations looking to create competitive advantage can leverage serverless architecture solutions to achieve rapid growth without significant capital investment. Not only do serverless architectures scale fast automatically, but they also incur cost based on usage, allowing businesses that use them to spend for exact cloud service they require. With a hyper-connected world and every device on the earth transmitting data of various formats, one of the most popular cloud computing trends is the rise of IoT platforms. IoT also supports different industry-grade protocols to deliver smart predictions through monitoring organizations. This intelligent connectivity is what makes IoT platform a cloud computing trend. Cloud-based artificial intelligence technologies, including machine learning, are also helping business draw additional value from the ever-growing volumes of data they collect. Out of the box, artificial intelligence algorithms and models from cloud vendors empower businesses to glean new insights from their data and improve the way they work. With the number of IoT devices increasingly exponentially, edge computing will play a very major role in providing real-time information and data analysis and streamline the flow of traffic from IoT devices. Hybrid and multi-cloud model. With its benefits, the market for hybrid and multi-cloud is expected to grow in future. It provides enhanced security and SaaS capabilities. These type of cloud models provide the desirable level of flexibility at reduced costs. Next, I would like to focus upon the advantages and disadvantages of cloud computing. When we talk of advantages, the cost savings is at the top of the list. It saves substantial capital cost as it does not need any upfront investment for setting up a private data center. Organizations do not have to manage the equipment and hire trained personnel to maintain on-premises hardware. This helps organizations to move from a CapEx model of IT budgeting to an OpEx model. It also provides a competitive and strategic edge over its competitors. Moving to cloud enable organizations to access the latest solutions developed in the field of technology without having to spend too much time and effort on understanding the specifics. Disaster recovery and data backup. Once the data is migrated to cloud, organizations can leverage the latest technology and solutions to easily back up the data and restore the backup when required with minimal effort and downtime. Cloud also provides excellent disaster recovery solutions with low recovery point objective and recovery time objective, which the companies can use to keep the business running uninterrupted for a long time. Reliability and scalability. Migrating to cloud provides enhanced reliability and scalability. The applications hosted in cloud can scale based on the demand of the customers. Some of the disadvantages of cloud computing is data confidentiality and compliance. Since data is available in the public domain, there is always a risk about the data being accessed by unauthorized users or PII and PHI data getting stolen. Although cloud technology has taken massive strides in developing robust security mechanisms to protect the data at rest and in transit, security remains the single most concerning factor for migrating applications and data to cloud. Vendor locking poses another risk for cloud migration. The cost of switching to a different cloud vendor is so high that a customer is essentially stuck with the original vendor and continue to use inferior solutions and services, which may impact their businesses. And finally, I would like to take a moment and thank the entire UMGC team for designing this course. It has enhanced my knowledge and gave me very valuable insights on the concepts of cloud computing. I thoroughly enjoyed being part of this course. I would like the UMGC team to include some advanced topics and latest and future cloud trends as part of the course. I also believe that there is scope to add more content for each week, which will certainly provide more knowledge to the people enrolling this course. Thank you.